So if anything, just cakap because I tak nampak you after this. So this kind of question, okay, we are doing question example yang nombor 3 ni. So where the soalan, instead of dia tanya what kind of hybridization, like this is type of hybridization, just bagi tahu it is sp ke, sp2 ke, sp3 ke. But now dia cakap describe hybridization process. Why this question is quite important? Because it holds quite a lot of marks. So sometimes it can be 6, sometimes it can be 8, and sometimes it can be even 10 marks. But it's good for you because cara nak jawab dia is very easy. You just follow the you only have 3 steps yang you mesti ada, and most likely you akan dapat 100% marks. Alright. So let's look on this kind of question. Tapi I'll give you a different kind of compound where the soalan suruh describe C2H2. Okay. So the very first thing yang you have to do, okay, kalau nak describe the hybridization process, the very first thing you have to do is you buat dia punya Lewis structure. Lewis structure. Okay, and then you kena tengok on dia punya central atom. Central atom. And finally, the third part of you nak jawab hybridization process. To describe hybridization process is you kena bagi tahu orbital overlap. Orbital overlap. Okay. Sometimes soalan tu is not only just describe the hybridization process. Dia akan separate kan by this is soalan A, and then soalan B dia suruh describe dia punya central atom, and 3 is dia suruh tunjuk orbital overlap. Untuk central atom, we have to talk about ground state and excited state. Okay, ground state is the state where the atoms is the most stable. Semua energy lowest, the lowest energy. Okay, excited state is the higher energy, okay, and the less stable. Okay, nanti kita akan tengok. So, what are the things yang we have to do untuk describe the hybridization process? Okay, so let's do the first one dulu So Lewis structure. So I takkan buatlah satu-satu macam kita kira valence electron semua tu kan. I'll just show you the Lewis structure terus. But in exam you have to do lah. You kena kira the valence electron. You kena tengok which atom yang tengah-tengah and which atom yang nak letak kat luar. But if you look C2H2, you tak tahu kan mana satu tengah. Okay, sebab adakah dia macam bentuk macam ini? Ini. Okay, actually untuk C2H2 dia punya bentuk is like this, where the carbon is joined with the carbon in a straight line, and the carbon actually forms a triple bond. Okay, remember nanti dalam exam pun, okay, you might know that C2H2 is like this, or you might not know. Okay, macam mana nak tahu which one is correct? Remember, kita cari dia punya formal charge, kan? Formal charge. So kalau you dah complete kan dia punya Lewis structure, you kira formal charge. Untuk the most stable is formal charge je mesti all is the lowest, kalau boleh 0. Okay, so this is dia punya Lewis structure. Okay, so mana ni? So from the Lewis structure, this is first part. The second part is kita kena tengok dia punya central atom. So how to describe dia punya central atom? So we just describe these two lah. These two we can consider is central atom, even though ada dua. So untuk describe central atom, kita describe dia punya hybridization. So what kind of hybridization yang dia ada? Okay, cara nak tengok hybridization, okay, kita only tengok the sigma bond. So this is sigma bond. This is one of these three is sigma bond. Lagi dua is pi bond kan? Kita ada dua pi bond, one sigma bond, and this is sigma bond. Okay, nak tahu the carbon is hybridization apa? Kita tengok the amount of sigma bond yang dia ada. Sigma bond only. Okay, so untuk carbon punya hybridization, carbon is ada 1, 2. So ada dua pair. So it is a sp hybridization. Hybridization. Okay. Sebab dia ada 1 and 2. Kalau dia ada 3, kalau contohnya carbon tu ada 3 sigma bond, they should be sp2. Sebab 1 and then ada 2 dari p kan. So, cara nak describe dia punya central atom. So, macam mana nak describe dia? Okay. So, first, macam saya cakap tadi, kita kena tengok ground state dulu. So, ground state dulu untuk carbon atom. Okay, untuk ground state, carbon atom ni ada berapa valence elektron? Ada 4 kan? Valence elektron. So, at ground state, dia punya valence elektron is dekat 2s dengan 2p. So instead of buat kotak, I buat line. Sama saja. Boleh juga diterima. Macam buat kotak pun tak apa. So, at ground state, dia punya electron is arranged like this. Okay. If you look like this, okay, it makes sense untuk dia do bonds of sigma bonds. Sebab dia ada 2 unpaired electrons. Tapi, it does not make sense untuk dia buat another 2 pi bonds. Okay. Macam mana dia nak buat pi bonds kalau dia only ada 2 unpaired electrons. Okay. So, cara yang after you buat ground state, you have to elaborate a bit. Okay. So, apa yang you perlu cerita is, okay, at ground state, okay, untuk matriculation, you boleh buat paragraph, tulis panjang-panjang macam essay, ataupun you nak buat point form pun boleh. Just remember, point form always kena ada complete sentence lah. Okay, at ground state, carbon, okay, carbon atom has 4 valence electron, right? Okay. And then you kena cerita pasal 2 valence electron tu, okay, I singkatkan sebagai VE as valence electron. Dalam exam, you kena tulis penuh jangan tulis VE. Because even though the pemeriksa tahu VE tu apa, everyone put VE as valence electron, dia orang akan pretend like tak tahu. So, 2 valence electron in 2s orbital and 2 electrons in 2p orbital. Okay, this and 2 unpaired. Okay, sorry, I terlupa. Okay, and 2 unpaired 2 unpaired electrons. Okay, and 2 unpaired electrons in 2p orbitals. Okay, so that is dia punya descriptions. Okay, so you kena cerita that in ground state, okay, dia ada 4 valence electron and then 2 valence electron ada dalam 2s and we have 2 unpaired electrons dalam 2p orbitals. So, untuk to make bond where dia ada pi bond juga and also 2 sigma bond, the electrons must be excited. So apa yang diorang buat is one of this electron is di excitekan masuk ke dalam 2p untuk jadi single pair juga. So it has a four unpaired electron. So untuk excited state,
Sir,
yeah.
sorry sir, ramai yang tunggu nak decide.
Okay, next time suruh diorang masuk awal I'll habis the question dulu and diorang akan masuk after the question. So,
Okay sir.
untuk excited state bila kita dah give energy to the atom, the central atom untuk dia buat bond. So it's ibarat like they have to pay something to get comfortable. So they need energy untuk form bonds where diorang lagi selesa untuk ada bonds. So at excited state dia ada, kita dekat 2s 2 3 2p and then we have 1 2 and 3 4. So description dia at excited state, carbon atom has one unpaired electrons in 2s orbital and 3 unpaired electrons in 2p orbital. Okay, so in this orbital barulah dia boleh buat bonds. Where? So kalau you tengok untuk buat bond, it is a 2s sp hybridization. Okay, untuk hybridization punya state, untuk hybridization, sebabkan tadi kita tengok kita only look on sigma bond kan, so it is only an sp hybridization. So sp maksudnya satu dari s, satu dari p. So hybridization is kita have 1 and 2 from sp punya hybridization, and we also have the 2 unhybridized. Betul ke saya eja? Kalau saya salah eja beritahu unhybridized p orbital. Okay, so this 2sp is where yang kita akan buat sigma bond, and we have 2 unhybridized p orbital. Dia stay as p orbital, dia tak hybridized langsung. So untuk dia punya description is the 2 unpaired electrons are in sp orbital, sp hybridized orbital. So basically pretty much apa yang you tulis is apa yang you lukis. You just nak describe balik apa yang you lukis sahaja. So it is a fail-safe because sometimes only lukisan is accepted and you already got marks. Sometimes kadang the question is a bit finicky, so kadang dia orang akan bagi 2 marks for this, 2 marks. Sometimes they only give 1 mark for the drawing and 1 mark for explanation, even though it is the same thing. Okay, and 2 unpaired electron in unhybridized hybridize p orbital. Okay, so untuk overlap, cara untuk describe the overlap, alright, orbital overlap. So untuk orbital overlap is the one where you actually have to draw. So let's look on balik apa yang kita actually have to draw. C and then H and then H. So we actually have to draw the orbital yang ada di this carbon and hydrogen in 3D space. But this one you tak perlulah sangat nak accurate yang macam axis semua tu. As long as it kind of conveys the correct punya orbitals. So cara nak lukis is you lukis dulu element. Okay, this is the easier way lah. Nak lagi the more the prettier way. So you lukis the element. So we have carbon, we have also another carbon, and then we also have hydrogen. Tak nak hydrogen dekat sangat. So tak apalah. So hydrogen and hydrogen. So the first thing yang you need to draw is the sp orbital. Okay, so I'll draw in purple. Okay, so carbon dia ada sp orbital kan? So it is sp orbital. Alright, and then kalau if you remember this carbon, the sp orbital have 2 unpaired electrons, right? This is yang involved in the sp orbital. So remember, it is covalent bonding, it is sharing an electron. So each of this carbon ada 2 unpaired electrons. So the satu dia share dengan hydrogen, satu lagi dia share dengan another carbon. Okay, likewise dengan this carbon, sama saja. So it is actually diorang are sharing electrons in the middle lah. Okay, kalau you tak nampak apa yang I lukis itu tu, dekat the overlap, right? Because I terlukis kecil lah pula. Dekat overlap tu is I lukiskan the shared electron. Okay, and then another shared electron yang dekat dengan s orbital is dengan H, which is H is H is s orbital kan? S orbital shape dia bulat. So sama juga. You labelkan dia punya shared electrons. And one thing is you need to label the orbitals. Oh, tak boleh label sini. Nanti tersangkut. Okay. So you labelkan the orbital, which is the sp hybridized orbital, and H is 1s orbital. Okay, tak semestinya tulis 1s, tak s orbital pun sama. Okay, so now kita nak describe dia punya pi orbital pula. Macam mana dia form pi bonds. So kalau if you remember, we have 2 unhybridized p orbital yang ada 1 singly paired electrons. So kalau you tengok, each of this ada 2 electrons yang singly paired yang tak dihybridize tapi dia share dengan each of the carbons. So cara dia is good untuk you guna different color, tapi kalau satu color saja pun tak apa. It is okay as long as you label. So we have the p orbitals macam biasa dekat z axis. Alright, so cara nak lukis dia is satu you buat spin up, satu you buat spin down. Okay, so this is same color lah. So this is one of the pi bond. So atas atau bawah sama. So we usually represent one shape je lah. Okay, the second pi bond is dekat dia punya melintang. Kita ada dua kan, kita ada contohlah ni z axis, this is maybe y axis. Alright, so between this and this, so also to lukis dia punya electrons. So yeah, one spin up, one spin down. Even though kalau you guys tengok tadi semua spin up kan, it is bila kita lukis actually the electrons orientate themselves in opposite way, so that they orang can form a bonds lah. Okay, and then so this is the second pi bond. So this is how you lukis dia punya orbital overlap. Okay, and then cara nak describe dia, right? So cara kita nak describe dia is you cerita satu-satu lah. So the sp orbital, okay, they overlap and form with another C atom to form pi bond. So you cerita pasal the sp orbital, sp hybrid orbital of carbon atom or overlap with another C atom to form a sigma bond. Okay, and then you cakap benda yang sama tapi dia overlap with s orbital of H atom to form sigma bond. Okay, sebab kalau you guys tengok untuk sp orbital ni, we have dia overlap dengan another carbon atom untuk form sigma bond, and also dia also overlap dengan s orbital of hydrogen to form another sigma bond. So we have two sigma bond actually. We have this sigma bond, carbon and hydrogen, and we also have carbon and carbon. Okay, benda yang sama lah, kalau sini pun sama. Okay, and then lastly is dia punya pi bond. Okay, the P, the unhybridized p orbital overlap with another p orbital of another C atom to form pi bond. Okay, so if you look, this kind of question is quite long, banyak explanation kan, and this kind of question sometimes diorang untuk the subjective, where it is one whole question and you have to jawab. So if you see the very first thing is you buat Lewis structure and find the most plausible structure lah. So the structure yang dia punya formal charge is 0 ataupun the paling rendah, and then you have to describe dia punya hybridization. Cara nak tahu hybridization, tengok berapa banyak sigma bond central atom tu ada. Central atom only, kita tak tengok yang atom lain. And then untuk ground state, you just tulis dia punya valence electron. Okay, so valence electron dia, valence electron, you just tulis valence electron pun tak apa. Kalau lah you rasa macam you don't actually know how many valence electron dia ada, you nak buat semua daripada 1s, 2s, 2p pun tak apa. Asalkan you, because ground state, you not actually we just tunjuk valence electron. The reason is the only valence electron yang form bonds, kan? So you just tulis balik apa yang you lukis je, itu sahaja. And then excited state is kita make it single unpaired electron untuk setiap orbital supaya dia boleh buat bonds. How many single unpaired electrons yang kita perlu, berapa banyak yang kita perlu is equivalent to total number of bond sigma and pi. Okay, berapa yang kita perlu is the total number of bond lah. So this is kita tengok carbon kan. So kita tengok carbon. So contohlah kita tengok this carbon. So kita tengok this carbon, berapa banyak bond dia ada. Dia ada 1, 2, 3 and 4. Same as this carbon, so dia ada 4. So dia perlukan 4 single unpaired electron. So that's why kita perlukan 4 unpaired electrons. Okay, you just cerita je dekat unpaired electron tu duduk mana. And then hybridization, kenapa dia jadi hybrid is, this is only untuk explain kenapa dia boleh buat pi bond lah. Okay, and dia punya geometry. So from this SP, kita only tengok dia punya sigma bond. So sigma bond ada 2, dia buat SP. So thus dia pun hybridized S dengan one of the P. So kita ada 2 unhybridized P orbitals. You cerita benda yang sama. And then dia punya orbital overlap. Okay, orbital overlap you kena lukis sikit lah. Okay, and then after habis tu, sometimes the question dia tanya molecular geometry. So the geometry, nak dapat mana? Geometry you tengok hybridization. Okay, geometry dalam ni we only look on hybridization. So it is SP. So maksudnya this molecule is linear. So don't worry, untuk hybridization only basic shape. We only have linear, trigonal planar, tetrahedral, trigonal bipyramidal and octahedral. Only 5 tu. So this is how you nak jawab this kind of question where disuruh explain hybridization. Okay. So do you have any question on explaining hybridization? Ada soalan ke?
Sir,
Yeah.
do I have to write the bond angle?
The bond angle also okay. It's good untuk kalau you tulis, but sometimes you orang tak tanya unless the question specifically ask for the bond angle. Maksudnya ada marks lah. Sebab this kind of question tanya pasal hybridization, dia more focus on electrons, on mana orbital dia pergi, orbital mana yang dicampur, and macam mana the overlap. Untuk geometry, you selalunya dia nak tahu what kind of geometry saja, unless dia specifically tanya. Okay, kalau soalan tu tanya molecular geometry, okay, dia just tanya molecular geometry, dia suruh lukis, dia tak tanya pun pasal hybridization. Hybridization tak tanya langsung. Angle, bond angle wajib ditulis. Kalau ini you just tanya, bagi tahu je. Boleh lah kalau you nak buat the bond angle, you nak lukis the bond angle dekat sini pun tak apa. Tapi just it will be too semak you punya lukisan. Because the bond angle kita only tengok sigma bond kan. So it is just 180 degrees. Itu sahaja. But untuk ni, you tak perlulah. Do you have any more questions? Ada soalan lagi ke before kita masuk on intermolecular forces? Ada ke? Korang semua okey ke ni? Later I'll I'll make this a PDF, even though tulisan saya memang cantik. Saya akan buat in PDF and saya akan bagi in Discord. Any question ke? Ada soalan tak? Before kita masuk on intermolecular. Ya. Okay. Ya, apa soalannya? Apakah soalannya? Cakap pun tak apa. Okay, 2B. Mana question 2B? So, indicate what type of hybridization of carbon and nitrogen atoms. So, ini disuruh indicate. Dia bukan describe. Untuk describe, itu yang you kena panjang-panjang tadi. Untuk indicate, you cuma perlu bagi tahu dia is type of hybridization apa. So, what I suggest you to do, okay, for example, this kan. So, NH2, CNH, and then NH, and then CH2, and then CN. This is actually kalau you nak lukis balik is organic chemistry lah, which is next semester. But you just lukis balik in bonding. Kalau you tak tahu, you kena buat Lewis structure lah. Tapi, yep. So, untuk this is actually dia punya formula is N, we have H and H, and then to the carbon. So, bila kurungan masuknya it is NH, and then another N, H, and then C, H, and H, and then C triple bond N. So the thing is, you kena 1, 2, 3 cukup. 1, 2, 3 1, 2, 3 here. It's like this. So this is an example of this is dia punya structure lah. So remember, nak tahu dia punya hybridization. Okay, untuk this nampak tak dia suruh draw the Lewis structure. So Lewis structure you kena draw one by one lah, and you actually kena buat all the possible one and cari formal charge dia. Kenapa this is the most stable, the most plausible one. So if you look, right, kalau dalam kurungan, maksudnya NH ni adalah, kalau this is we call ligands, where dia bukan dalam straight change tu. Okay, nanti you guys akan belajar dalam organic chemistry semester 2. So disuruh describe, indicate the type of hybridization untuk nitrogen and carbon sahaja. So nitrogen, 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 carbon, carbon, nitrogen. Okay, and remember only look on sigma bond only. So sigma bond only, right? So tengoklah dekat nitrogen ni ada berapa sigma bond? 1, 2, 3. So kalau ada 3, maksudnya dia ada 1 s orbital. Nak cukupkan lagi 2, dia perlukan 2 p. And then look on this carbon, ada berapa sigma bond? 1, 2, 3, 4 ke? Ataupun 3 ke? 4. So remember, we only look on sigma bond. Okay ke soalan 2B tu?
Sir,
Yeah.
is lone pair considered a sigma bond?
No. Lone pair is a lone pair. Okay. Untuk hybridization, kita only look on sigma bond only. Lone pair kita ibaratkan dia tak hidup. So, the only time you guys akan tengok lone pair is molecular geometry. Dia tanya molecular geometry. So, you look on lone pairs because lone pairs, kehadiran lone pairs will indicate the initial shape. Okay, shape yang pertama, yang original shape before distortion. Okay, Bila ada lone pairs, so contohnya kita ada satu lone pairs and ada 3 bonding pairs. So it is original shape dia tetrahedral lah. Saya tak bawa saya punya molecular shape. But sebabkan ada lone pairs tu, kita ibaratkan lone pairs tu tak wujud, dia adalah trigonal pyramidal. Like that. Okay ke? Okay ke?
But sir, if for example like nitrogen,
Mm-mm.
dia ada 5 valence electron kan?
Mm-mm. Betul.
And in the s orbital there are 2. There are pair of electron already. So yang tu kami indicate as lone pair kan?
Yes.
But if we are to hybridize the orbitals, aren't that S tidak hybridize dengan p orbitals tu kan? Sebab S tu sudah penuh.
Okay. Later can you type your question? Because nanti you tanya kat Discord, okay, and I'll get back to you with that question. Boleh?
Okay, sir.
Okay. So now let's look on, sebab all this time kita tengok pasal those covalent bonding, ionic bonding, dative bond, those are intramolecular. Maksudnya intramolecular forces yang dalam molekul. So contohlah this is hydrogen and fluorine. So hydrogen and fluorine. Those yang kita tengok semua is the bonds yang I represent using this benang. So I jahit kan. So that is the bond. Okay. Untuk 4.4 kita akan belajar intermolecular forces. The forces between molecules and other molecules. Right? So generally we are looking at a weaker force. Sebab now kita akan masuk 4.4, we are looking at weaker force than covalent bonding, because kalau I tarik, the first force yang akan fail is dia punya intermolecular forces between molecules. Okay. Untuk soalan tadi nanti Sam, you hantar dekat Discord, I akan give you the answer balik dekat Discord lah. I letak dekat chat nanti. Okay. So let's masuk on 4.4 intermolecular forces. Okay. So what are the significance of intermolecular forces? So this is the thing yang kita akan belajar. Polarity and dipole moment kita dah tengok sikit, and then kita ada intermolecular forces, kita ada 2. Kita ada van der Waals forces and hydrogen bonding, and van der Waals forces pula dibahagikan kepada 2. You have dipole and London forces. Okay. And then later kita akan tengok hydrogen bonding, and kita akan tengok why water is denser than ice. Okay. This is the general formula of polarity of a bond. Okay, where it is the dipole moment yang hari tu kita buat by using an arrow has a value, while the value is represent as mu, called dipole moment, where Q is the charge. Okay, dia punya charge plus 1 or plus 2 plus 3. If I'm not mistaken, this formula juga ada dalam physics, where you describe pasal charge. Is it electric kot kalau saya tak salah. And R is the distance. Okay, don't worry. Untuk chemistry, you only know the formula, but you don't really have to know the calculation lah. Okay, tak banyak soalan yang pasal calculation. Just know that unit dia is debye. So dia bagi dalam 4.3 debye. Maksudnya it is the dipole moment, dia punya magnitude is 4.3 lah. The higher the number, the more dipole it is. The more polar it is lah. So this is a general idea apa yang affect polarity. We have electronegativity and molecular geometry. Okay, electronegativity most likely is electronegativity difference. Betul ke saya eja? Kalau saya salah eja bagi tahu Kadang saya pun dah lupa secara ni eja. So, it is kalau dua-dua bond tu, contohnya macam C dengan H, dia orang punya electronegativity value is not that different. So, it is non-polar. Ataupun a very polar elements, contoh fluorine. Fluorine is the most polar element, which is the value sometimes dia orang cakap 4 ataupun 3.83 kalau I tak salah. Okay, it's very polar. Okay, dia suka sangat elektron. Tapi kalau dia bond dengan diri dia sendiri, F, bond dengan F, they have the same polarity, same electronegativity. Thus, dia orang tarik elektron tu sama-sama, making the bond is non-polar. So, the only polar molecule is bila kita ada elektron positif and elektron negatif atom. Contohnya hydrogen dengan fluorine, hydrogen and chlorine. Okay. Despite that, the molecular geometry also affect the shape. Walaupun each individual atom ni is each individual bonds is polar, tapi kalau shape, okay, kalau shape yang basic, maksudnya linear, trigonal planar, tetrahedral, trigonal bipyramidal, kalau di shape basic, it is non-polar. Sebab it cancel out each other. It cancel out the dipole moment. Okay, kalau lah shape tu yang non-symmetrical, which is kalau ada lone pair. So instead of tetrahedral, but now apa benda lah bunyi tu. Okay, contohnya macam ni. Okay, contoh this is fluorine, contoh, but it's not, tak ada lah. So now it is polar sebab dia dah tak boleh nak cancel out each other. Alright. So let's see the example of hydrogen fluoride, which is a polar molecules. Okay, fluorine is more electronegative than hydrogen, and then so fluorine had tendency to pull bonding electron toward itself. So actually, kalau bonds untuk hydrogen dengan fluorine, kebanyakan electrons duduk sebelah fluorine dan hydrogen, thus making hydrogen having a partially positive electronegativity, and untuk fluorine has a negative one, where kebanyakan elektron ambil. So this is dah ibarat dengan ionic bonding. So where kebanyakan electrons ada dekat fluorine. Okay, and kita can represent the direction by using an arrow lah. Macam hari tu kita dah cerita pasal polarity. Untuk CH, okay, carbon is 255 and hydrogen is 2.2. So actually this molecule is non-polar sebab dia punya difference pun dah tak banyak. So actually diorang punya tarikan electrons tu is quite spread out equally. Alright. So what if kalau diatomic molecules contains different elements pula? So instead of HCl and NO. Contoh carbon dioxide. Okay, carbon is macam tadi 2.55, while oxygen is 3 point something lah, saya tak ingat. I think 3.6 ke 3.5. Tak bawa saya punya electronegativity value tu. Okay, even though this bond is polar, tapi okay, we have a polarity of like this, right? Tapi now it cancel out each other sebab molecular geometry dia is linear, it's the basic shape. It cancel out each other, kiri cancel out kanan. It is a vector quantity, so dia ada direction. So it is becoming non-polar molecules. Sama juga macam tetrahedral, even though you susah lah sikit nak nampak dia cancel out each other, just rest assured as long as it is a basic shape, it cancel out each other. Basic shape je dia cancel out each other. All of this dia cancel out the dipole moment, making this this molecule non-polar. While dichlorometate, okay, even though dia basic shape, tapi you tengok bond dia tak sama. This is bond dengan carbon dengan hydrogen, while this is carbon and chlorine. So actually tak ada siapa nak cancelkan chlorine ni. Carbon and hydrogen, diorang tak polar, so diorang tak boleh nak cancelkan chlorine. So it is polar molecule. Alright. Kenapa kita belajar polar, non-polar molecules ni? Okay. If you know, siapa sini yang pernah buat test COVID yang you beli tu, yang berapa? RM19. Dia macam kotak, and then you ada letak saliva, and then you akan nampak dia punya lines tu kan? I cannot remember. I think T dengan C ke? Macam tu. Okay. This is a type of usage of polar molecules, where you punya saliva, you ada kumur dengan benda something kan? So you letak. Okay. The polar antigens, where yang ada COVID, dia akan naik to the COVID parts. Kalau tak polar, dia akan naik ke negative parts. Which is, that's how dia orang nak tengok you ada COVID ataupun tak. Okay. That's why it is important about polarity. Okay. Even, okay, ammonia, the molecular geometry is tetrahedral. Tapi molecular shape dia is pyramidal. Sebab remember kita bayangkan nitrogen sebagai kita bayangkan lumpur sebagai dia tak wujud. So it is a polar molecules sebab it is pulling the electrons toward the nitrogen. So it is having a net dipole moment. So it is a polar molecule. Okay, untuk net dipole moment, usually kita represent mu sebagai not zero. Sebab we don't really need to know the exact number of mu. We don't really need exact number of berapa dipole moment dalam unit nearby. As long as dia bukan kosong, dia ada net dipole moment. Kosong je, dia ada zero dipole moment, which is non-polar. So now, lepas kita habis polarity, now kita akan masuk intermolecular forces. Yang saya cakap ada dua, van der Waals and hydrogen bonding. Selalunya dalam question, pelajar jawab betul, tapi ejaan salah dikira salah. So remember it is van der Waals. Okay, jangan nanti saya tengok orang jawab macam ni, korang datang kolej saya cubit korang. Okay, so we have London and dipole interaction. Okay. So the real name is dispersion forces and dipole forces lah. So untuk some books, sesetengah buku dia orang call it London forces and permanent dipole. Okay, just know they can have two names. Okay, because how chemistry works, orang dulu suka bagi je nama apa yang dia orang suka. So dia orang jumpa forces ni dekat London, orang tu duduk dekat London, dia bagilah nama London forces. Alright. Ataupun kalau orang tu jumpa kat Kuching, dia bagilah nama Kuching forces. Okay, but as we progress, kita give it more scientific name. So kita give it dispersion forces and dipole interaction. Untuk exam, it is permittable untuk guna mana-mana nama, London or dispersion, ataupun dipole ataupun permanent dipole. It's okay. So this is dia punya relative strength, where hydrogen bonding is the strongest of them all, while dipole is in the middle, and London is the weakest one. Tapi there's a stronger force. There's a stronger force where it is intramolecular forces. Intramolecular. This intramolecular ni yang kita cerita pasal hybridization apa semua tadi tu, which is covalent, ionic, and dative. Okay, these are the forces yang way stronger than intermolecular. Okay, so I think ada question ke? Oh, lag ke tadi? Sekarang okey ke? Kita okey tak sekarang? Okay. So now mana pergi tadi? Sini. So there's two type of van der Waals forces. Okay. One is dipole-dipole. Dipole-dipole is only on polar molecules. So take note on that. Dipole-dipole only for polar molecules. Where kalau polar molecules kan electrons are more ditarik ke electronegative punya atoms. So you have a partially negative charge and partially positive charge. And as you know it, positive and negative attract each other. So negative attracts to negative attract to positive, and likewise negative attract to positive. So this is dipole-dipole forces. Just remember, it is only for polar molecules yang boleh ada dipole-dipole forces. Kalau it is non-polar, it cannot have dipole-dipole forces. Right? This is a dipole-dipole forces. So, describing dipole-dipole forces. Okay? Lagi polar, which is usually higher electronegativity difference. So the stronger dipole-dipole forces tu. Sebab dia ada stronger partial and stronger partial positive and partial negative dia orang lagi stronger lah. So more energy yang kita perlu overcome. So that's why the boiling point untuk polar molecules is higher. So untuk this kind of question, usually dia orang akan tanya pasal boiling point. So describe, dia orang akan bagi two. Contohnya is CH4 dengan HF. Okay, dia orang akan tanya mana has higher boiling point. It is HF sebab it has higher electronegativity difference. Like that. Okay. This is one example lah untuk dipole-dipole forces. So we have propane and acetaldehyde. Acetaldehyde has carbon and oxygen, di mana dia orang punya electronegativity difference is quite high. Tengok, dia ada dipole moment. While propane 0.1 ni is negligible. And tengok dia punya boiling point, it is higher sebab dia ada dipole-dipole forces tadi lah. Dipole-dipole force tu, dia attract each of the molecule closer to each other. Dia ada bond, dia ada extra bond. Okay. Now, how about London forces? Okay. So, London forces ni is for temporary dipole moment. Okay, take note, it's only for non-polar. Kalau dia tak ada polar, contohnya bromine and bromine have the same electronegativity, so dia non-polar lah kan. So, it has London forces. Okay, just remember, kalau polar, terus dipole-dipole. Kalau dia tak ada polar, terus London. So, look, kenapa satu bromine kecil, satu bromine besar? Do you remember what is an orbital? Orbital is a 3D space where electrons, the probability of finding electrons is the highest. Okay? So, even though kita tahu bromine like this, it makes sense, kita tahu dia punya atomic radii, but at any given moment, so bromine ada 7 kan? 1, 2, 3, 4, 5, 6, 7. Okay, at any moment, so ini pun ada 7 elektron. These electrons tak semestinya duduk sini saja. At any moment, sometimes dia rasa macam nak rentas negeri. So dia pun rentas negeri tanpa kelulusan polis. Dia pun duduk, jadilah bromine ni lagi besar. So that's why it is called temporary dipole moment. Dia tak duduk lama-lama sebab nanti polis tangkap dia. So dia pun rentas negeri balik rumah dia. So at a temporary moment, we have a partial charge. So this partial charge yang make the London forces. That's why it is the weakest. Sebab dia hanyalah sementara. Okay, nothing lasts forever. So dia patah balik having no charge. So dia macam sekejap ada tarikan, sekejap tak ada tarikan. Like that lah. So what affect London forces? Okay, bigger molecules with all higher molecular mass has more electron to move around. So lagi senang dia nak gerak lah. So lagi senang dia nak rentas negeri. Lagi senang dia nak pergi ke another atom tu. So having London forces. So that is kita punya point untuk cerita pasal dia punya boiling point. So like that lah. London forces is the weakest. Okay, kalau ada polarity that's higher. So contohnya kalau perbezaan between chlorine and bromine. Okay, bromine is bigger than chlorine. So elektron dekat bromine easier nak rentas dia punya negeri dia. So bromine is higher boiling point than chlorine sebab dia easier to polarize. Okay, not only the size of the molecule and the weight, we also look on the shape. Okay, kalau N-pentene, okay, pen dia ada 5 carbon. Okay, kalau you guys tengok 2,2-dimethylpropane has larger surface area, thus lagi senang nak polarize. Okay, sebab kalau untuk N-pentene the electron punya cloud is all compact like a ball, while 2,2-dimethylpropane diorang panjang, so it is subject to changes. Maybe ada a polar molecule dekat sini dia tolak, making this electron dekat sini tergerak ke sini, so having a polar moment. Okay, while kalau sini most likely a lot of it akan terasa, diorang terasa equally instead of here, so it is less likely to get polarized. Alright, so kita dah habis van der Waals forces. I'll cerita about hydrogen forces, hydrogen bonding, and then kita akan habiskan kelas kita. Okay, hydrogen bonding. Okay, hydrogen bonding ni special. It's a very special bond. It is one of the reason that kita orang suspect that life can form on Earth. Kenapa boleh ada kehidupan dekat bumi, right? It is only between hydrogen. Obviously nama dia hydrogen. Okay, hydrogen bond mesti dia dengan hydrogen, dengan these 3 atom only. Okay, dengan atom lain dia tak boleh. Only FON. Cara nak ingat, it is hydrogen phone, FON. These 3 atom sahaja yang boleh buat hydrogen bonding. Alright, so how does hydrogen bonding forms? Okay, hydrogen bonding is formed with only with highly electronegative atom, which is these 3, and is between the hydrogen and these 3 atom only. So hydrogen dengan fluorine, hydrogen bond. Example of hydrogen bonding: ammonia. So liquid ammonia, the hydrogen bond is between the hydrogen and the lone pair of the nitrogen. Or water, this is the most prominent, is between hydrogen and the lone pairs of oxygen. Alright, so most of the time hydrogen ni, sebab hydrogen, kalau you remember, hydrogen is 1s, 1. Okay, they only have s orbital, so it has a lot of space untuk accommodate lone pairs. So dia suka. So hydrogen ni is the elemen paling miskin lah. So elemen paling miskin dalam periodic table. Dia suka kalau orang nak bagi elektron kat dia. Dia suka. So it boleh bonds dengan the lone pairs of oxygen. Water is special because dia boleh buat dua hydrogen bonding each. Okay, sebab oxygen ada 2 lone pairs, so dia boleh buat 2 hydrogen bonding with 2 different hydrogen. Okay, so let's see the difference between ethanol, where it can form hydrogen bonding, tapi kalau etanol tu duduk dengan methane, okay, dia tak boleh buat hydrogen bonding. Kenapa? Kenapa dia tak boleh? Sebab untuk hydrogen bonding, this is very crucial. Untuk hydrogen bonding, hydrogen tu itself must connect to F ataupun O ataupun N. So hydrogen ni connect dengan oksigen, so it's okay, dia boleh buat. Tapi kalau hydrogen tu connect dengan carbon, dia tak boleh buat hydrogen bonding. Okay, untuk hydrogen bonding, H dengan F, O, N. Okay, dia mesti ada hydrogen yang connect dengan one of these three, and dia boleh connect with another hydrogen yang also connected with F ataupun O ataupun N. Okay, so this is the forces kita pasal tadi, sama je. Okay, and this is the effect of hydrogen bonding, and kita akan cerita pasal why water is denser than hydrogen. Hydrogen pula, denser than ice. Okay, kalau it makes sense, kalau you tengok contohlah mercury, liquid mercury is less than solid mercury. Okay, kalau you bekukan mercury, you letakkan dalam dia punya liquid mercury, which is dalam thermometer tu, dia akan tenggelam. Tapi kenapa ais semua terapung? Okay, ais terapung dalam air sebab those H2, ingat tak saya cakap dia boleh buat dua hydrogen bonding. Okay, it create an hexagonal crystal. Dia buat, you punya ais tu is actually a type of crystal where dia ada banyak empty spaces. So nampak this empty spaces. Alright, and it is, kalau you remember, density is dia punya mass over volume kan. So kalau volume dia banyak, so it having a lower density. So this is it is a tetrahedral punya shape where it creates a lot of empty spaces. So that's why. So tapi jangan to be confused with kalau ice, korang nampak ada air bubbles dalam tu. Those air bubbles are not the empty spaces. Those air bubbles are formed sebab you sejukkan dia cepat. Okay, this is a space yang you tak nampak lah, is between the molecules. So that's it untuk kita punya kelas. Later saya akan buat video on 4.5 and tengoklah.